session, you cannot hear anything. So earlier it was a bit too chaotic. So wait the end of the questions before leaving, please.
Okay. Thank you for everyone for coming today. We're going to talk about MyRocks in the Wild Wild West. And to start the talk, if you haven't met, please add me on Twitter or follow. My name is Alkan, and I work at Percona in Managed Services Department as Percona and a few other people over here. Today's agenda will be I'm going to introduce MyRocks and talk about some of the background and some notes. We won't get into too details. The slides will be available, and I will provide a lot of links, blog posts, and information. And if you want to ask questions, you can reach out to me or some others in the references. So what is MyRocks? MyRocks is a storage engine. It's a hidden gem in MySQL, as I call it, because it exists there for a while and not many people know or use it. And it's basically a key value store that is added to MySQL. It's based off of RocksDB, and it was also a fork of a LevelDB. So these technologies existed for a while. It's forked, and it had its own use cases and started using. Of course, this was needed for some large operations, and we know that it's been implemented in Facebook. And others also still use it as a RocksDB or MyRocks distribution. There's a link provided. There's some new blog post that actually identifies a few areas of interest that actually utilize RocksDB. And initially, it was a source code. Then it was kind of picked up some attention and brought into attention of the MySQL product providers other than Oracle, like Percona and MariaDB, and released. So how do we get MyRocks? We get it via Percona server or MariaDB. Percona server introduced this in 2017 and fully supported in 5.7 and 8.0 releases. And it's been also available for a while in MariaDB from 10.3 and 10.2 later distributions. Basically, they come built in. You don't need to do extra download or anything like that. It comes with, if you download Percona server 8.0. I think 18 is the latest version, it will come along with that. There are some differences between the distributions. So one main difference is the Facebook distribution. Facebook doesn't use the mainstream version of RocksDB, MyRocks implementation, and the Percona server has some different implementations for the compression algorithms, and there are some minor differences in the data file locations. The other thing that I wanted to highlight over here is the gap lock detection. This is like something major in the way that the engine works. So the Percona server and the Facebook, it supports. Facebook doesn't actually use it. Percona server errors out, and the MariaDB, there's no gap lock detection in the MyRocks engine. If you want to read about some details, there will be some links which we won't get in now. Okay, going back to the key value store. So we have the InnoDB engine versus LSM3 style, which MyRocks utilizes. I actually had to put up this infamous page and the link over here. Please have a read. So the way that it works is data streams of key value pairs actually written in the mem tables, which is the memory actually, and then they're flushed to the disk in a level format, and the compaction happens in each level to create a small, larger, small number of files. That's the main difference between the B3 and where B3 actually handles the data stream is slightly different than the LSM. So this is the right picture is what the MyRocks actually utilizes. So in short, over here, the B3 actually mostly read optimized, as we know, uses buffer pool, utilizes and actually writes are in place, and the LSM3 the writes are sorted string tables are written in sequentially, and then the compaction happens in the background from the algorithms that we mentioned above. You could choose your algorithm, and then has a fast access to data. Continue on the InnoDB. So not undermining what InnoDB can. InnoDB is a very powerful storage engine and can be used in other areas of Galera, library, write set replica, and Percona extra DB cluster, or group replication, where MyRocks is not. InnoDB also provides different binlog formats that in MyRocks we have to be in the raw format, and the transactions are limited to memory in MyRocks. So if we go back to MyRocks and the components of the MyRocks, I'm going to skip this and show you how the write request is handled. And basically we have the mem tables, the write ahead log, which actually they go along together, and then the leveled LSM tree structure that actually does the data writing, and the compaction happens in the background. For the logically partitioning, we have also column families. And when a write request comes in, we have the active mem tables are actually written immediately with the write ahead log, and then they are flushed to the sorted sync files, and the compaction happens on that level. And this allows the fast write and sorted files to be available in the disk. So we have a concept of logically partitioning the data with the column families, and the mem tables actually allow the writes to happen fast, while we also have a log of it written in the storage and then gets flushed to the table. So they are limited to 64 megabytes and a fast read and write optimized. The WAL is a write ahead log, which we actually compared to our InnoDB's reader logs, and when an immediate write happens, it's also written into the log. This also helps the crash recovery of the engine. And the MyRocks actually the similar way on the read request, actually the opposite way of trying to achieve that information process via memory tables, and then which is similar to buffer pool in InnoDB. And then with the index and the Bloom filters, you can actually access to those leveled and compacted data files, and then retrieve them fast. So the level compaction is also targeted for different data sizes, and as the compaction happens, it gets in a larger and larger. The fewer level is better, but if the data size is big, then you have actually fewer files that are already sorted and merged into different files. And there's more details about Yoshinori's tutorial over here. There's a link. It's a very detailed explanation that he made. So there are some improvements over the compaction. So they are aligned with the operating system units, and then also the Percona server. There has been some tests and benchmarks made in different algorithms. LZ4 was selected as the medium level algorithm, and then there are other compression methods that are also available. So the column in the other component over here that wanted to highlight is the column families. So it actually allows the partitioning of and the column families also allows us to configure MyRocks properly depending on the data set, and that's all the configuration parameters, which we will not get into it today, but you can actually have a more control over the data, how it's been accessed. So there are some advantages on the disk versus InnoDB on the LSM side, and there's a the lower write penalty and reduced fragmentation over it, and so this is being advised as a good fit for the write heavy workloads. Also, there are some advantages on the flash. With the compaction and the compression, you get actually saved space, and there is a lower write amplification for writing on the flash. We mentioned about the gap lock, and there's a row locking available. It's only read committed and repeatable read, and then we don't. MyRocks doesn't support gap lock as much as the InnoDB. For the replication side, it has to be row level, and then they'll have a large bin logs, and again, once again, the statement-based replication will cause gap locks, but you can still use it on the slaves. So this is the high level of MyRocks engine, and then how do we actually mix and match? It is not very much advised to mix and match InnoDB engine and the MyRocks engine at the same server, but if you do, the extra backup still works. It's only on 8.0 with the later versions of extra backup, and it's both optimized to take a backup of InnoDB and MyRocks at the same time, and there are no partial backups, so you can't actually write on an InnoDB and write on MyRocks, maybe like a different application, different the model. You can't say, okay, I just need the backup for MyRocks. If you have the backup, you have to back up the whole thing. You have to design it that way. MariaDB also, Maria Backup also supports after 10.2 on later versions. They don't also support MyRocks partial backups. There's also a MyRocks hot backup tool that was originally designed to back up the RocksDB and the checkpoint and the log file, but that's only for MyRocks. So there's a trade-off between using the extra backup, Maria Backup, or the MyRocks hot backup, and that way you have to be cautious about what's your recovery method is. There is also MySQL dump, and you can basically dump the data from MyRocks. And right now, snapshots are kind of difficult when you're mixing the engine, and then on the MyRocks side, you have to have the checkpoint and the log to be able to go into that point of recovery. So if we go back to the other tool compatibility, let's say we have a MyRocks engine in our ecosystem. So, okay, PMM is Percona Monitoring and Management Utility. It has built-in dashboards. So what that means is you have system and catalog files, information schema, information that you can actually gather, show engine, RocksDB status output. That information is there, so that tool is we consider it's compatible. You can actually monitor, analyze, and record the events. The extra backup is supported. For the online schema change, it's partially supported because it's read committed, and PT table checksum and sync you can't do it with because these are required to have a row level bin log. So that's the tooling compatibility. You need to plan ahead of time if you're actually going to test MyRocks and how my tooling and automation and other stuff works. Okay, this is the benchmarks aren't the subject of this talk, but as a reference, we wanted to have an example over here. I will not go into too much details, which when these tests were ran, we were on 8.0.16. Now we are on 8.0.18 and on engine. There has been some optimizer changes lately, and then we believe there's some numbers might be skewed because of that. I am from Percona. Percona's engineering department is working on new benchmarks, which I will also work with some other friends over here to analyze. But we can see as the threads are higher, the InnoDB gets kind of saturated, but the IO-bound network RocksDB excels in the sysbench TPCC test. I'm sorry. These are writes. And then we have also read and write tests over here. Same thing over here. You can see in the RocksDB as the 64 threads and more, it excels over InnoDB engine. Like I said, we will share more benchmarks and details about the latest developments with the latest version we have. and then compare some of the data versus. But the highlight of the RocksDB MyRocks engine is to have a larger data set write optimization. So so why would you use MyRocks? Because now there's most of our clients are in cloud. They pay per disk and disk space. So your costs are not going to be just, okay, I have these storage unit and it's going to run in the background and I can use it. This is like as you provision more. There's a link over here for another blog post that there is a comparison. The chart is very small, but it's cost efficient for cloud, as you can actually utilize and use different compression algorithms to get more out of that than InnoDB. I mean, there are some numbers that Yoshinori actually shared earlier about comparison between InnoDB compression versus the compaction that RocksDB provides. It's much higher, so that way simply you can save cost in the cloud or your storage. In conclusion, we think it's big for big data sets are actually more suitable. If you have a lot of indexing, and again repeating over here, for the write intensive workloads are actually much more suitable that we think. So basically the data that has a read-write type or a style of applications that actually you're writing and reading quickly, and that might be suitable for that. The other thing I wanted to mention is earlier, the RocksDB as an engine, as a technology, is used in some other areas. They're not like, as far as we know, they're not like MyRocks implementation of the engine, but the technology that relies, underlying technology that's in the RocksDB is being used in several other implementations. There's a blog post and a link at the end of the slides. And I wanted to also thank Yoshinori and Vadim Sveta and Mark especially. They put in a lot of work in RocksDB, and Yoshinori is over here if you have any questions. And there has been extensive research and development to come to this level where Facebook is running with the migration of RocksDB. And thank you.
You have time for questions.
Okay. Are there any questions?
Do you make any comparison between MyRocks and Tofu?
Can you repeat the question?
You have to repeat.
Oh, I have to repeat. Okay. Okay.
The mic.
Oh, the mic, because of the mic. Sorry. Okay. Okay. The comparison between the MyRocks and the TokuDB. We have initially made some comparisons, and I will have to look up those. The TokuDB is also similar technology. There are similar use cases that, but all the data that we had or I found, they were all outdated. So there are really no good comparison. And as MyRocks is being kind of accepted, both Percona server and the MariaDB server adopted into it, it's going into production as one of the largest web scale MySQL topologies in Facebook. We don't find too much value in going back and doing testing in TokuDB right now. So more like more InnoDB, MySQL 8 comparisons where you actually have an option. Do I actually have a benefit from RocksDB, MyRocks implementation? Any other questions?
You said you're using Bloom filters?
Yes.
I mean, most people nowadays moving to quotient filters, which are much more efficient and faster. Like Facebook just published the implementation in the Foley library.
Mm-hmm.
Maybe you could try that. I mean, it's an approximate dictionary, but it's much more efficient than a Bloom filter. So.
Okay, so it's not really a question, but it's more like a suggestion and commentary. Okay, so yeah, I don't know much of details on that, but we'll have to look at it.
What was the question? We're suggesting to use quotient filters, which are like better approximate dictionary that filters like the one that's developing as Facebook now, if they are in the Folly library.
Okay, so it's more like a suggestion to use different filters than a Bloom filters is the question. Yes?
How updates and deletes are handled?
How updates and deletes are handled?
Yes.
Okay, so so how should I? Okay, how updates and deletes are handled? Basically, we had a slide over. I think over here. Let me see. Let's look. We still have time?
Yeah.
Okay.
If not, Jan will tell you.
Okay. So basically, the way that it works is the mem tables are handling the writes, and when they actually the sorted strings come in when there's an update, you have the merging. So the writes are coming in and the updates are coming in for the data, and as you already compacted and leveled the data into the files, those sorted strings, and it gets actually basically it's flushed and redone in the memory. So basically it's an ongoing operation as far as I know, how it's handled.
So it needs to be remerged later.
Yes. Any other questions? Monty.
One has gap locking. Does it mean that you can run statement based? Because the only reason you can run statement based by default is because
Right.
lack of gap locking.
Good question. Does Percona have gap locking? It doesn't have a gap locking. It has a gap locking detection. So it actually detects there's a gap lock.
You mean there could be a gap lock,
There could be a gap lock, yes.
a conflict, gap lock conflict.
Yes.
So you basically error out.
Error out, yes.
That also means that you can support statement based.
You can have, yeah, well, you can have mix and match, but you can't support it. So, but it detects that there's a gap locking. Yes.
So could you get some feature for migrating from Windows to MyRocks? Because MyRocks doesn't support gap flow. So the problem is that any statement relying on gap flow will fail. It's like,
In other words, an update of a range email.
yeah. It's statement. So it's pretty much useless. So you have to
Okay.
use that.
But it kind of, the slides kind of indicated that Percona has gap locks.
Yeah, the detection.
It's the detection.
Even the basically statement fails who uses range, the update.
Range update,
It's
yes.
not the same as gap locks. Has nothing to do with gap locks. Exactly. You are saying that you could clarify that a little bit more in the slide.
Okay. Thank you.
Okay, thank you.
Thank you. Thanks for the question.